Have you ever had one of those, there's got to be an easier way to do this moments? Well, this might be one of them. Using a number line, the ideas we had from the first video about left and right directions for negative and positive numbers, I'm going to show you what this really means, an easier way to do these kind of sums, and why we need this kind of process. Using what we learned in video 1, this can be expressed as a set of steps going to the right from 0. As we saw in the first video, this would be the same as starting at 0 and just going 21 places to the right. This is how sums work. The difference this time is we have a repetitive sum. This does crop up a lot in the real world. Adding over and over again the same number would become tedious after a while. For instance, imagine selling business to business 1,000 $3 items. Would you really want to have to count those up? Luckily for us, the Babylonians developed the idea of multiplication about 4000 BC, probably from all of those warehouses they had. Well, regardless of the reason for it, it certainly is easier to reduce the addition problem here into a two-part multiplication problem. Now that we know what multiplication is, let's use the number line to discuss some facts about it. As we discussed before, 7 times 3 is the same thing as 7 sets of 3. Notice that if we take 3 sets of 7, we get the same result. Both of these would be the same as starting off at 0 and simply going 21 steps to the right. The first thing that we notice is that 7 times 3 is the same thing as 3 times 7. The number line is a good way to show that multiplication, like addition, is commutative. And once again, we see the idea of equivalent forms. Now that we have established some preliminary ideas, let me show you how the number line can help us address some challenging problems. In order to help you understand multiplication better, I'm going to use a number line and then use a visual representation to describe what multiplication really means. Let's agree that the first number in a product is the number of steps we're about to take. Then let's agree that the second number is the size of each step we were about to take. In this case, we're going to take 4 steps of size 7 units. This is equivalent to starting off at 0 and going right 28 places. This is what we mean by multiplication. And since multiplication is just an extended version of repetitive adding, this should make perfect sense. Before we tackle this problem, let's talk for a moment about its form. Notice the size of each step. What's different about this? For one thing, the size of each step is a -7. This means these steps are going off to the left from 0 instead of the right. But why did I put this in parentheses? As we will see in time, there are many different ways to express multiplication. In this case, I'm taking 3 steps of -7. When multiplying by sign to numbers, it's a good idea to put the negatives in parentheses to avoid confusion. Visually, it works like you would expect. The result, as we would expect, is -21. In this case, the size of the steps is positive, which means you would think they would go to the right, but the negative on the number of steps tells us these steps are flipped, so we're going back to the left. Because of that, we know that our result is -10. Finally, let's talk about the situation where both the number of steps and the size of each step are negative. Talking this through, the size of each step being -3 means we would normally go to the left. But because the number of steps are flipped, this is going to take it back to the right. Both of them being negative is always going to make it positive. When I was in school, we were always taught that if you multiplied with same signs, it was always positive and different signs negative. But to me, the visual representation always made more sense. In fact, you could come up with the rules just by knowing how the directions work on a number line. Thank you for viewing my third video. Next up, we will be talking about exponents. In particular, I'm going to show you how to develop the entire exponent rules from just a simple definition, and then show you how to use them. See you then.